In this video, we're going to solve the following word problem. Let's suppose that a company pays monthly salaries of $5,500 for every production worker and $4,600 for every assembly worker. Then suppose something happens so that the company decides to reduce its payroll from $400,000 to $347,600. And they're going to accomplish this by laying off 20% of the production workers and 12% of the assembly workers. Our goal here is to determine how many layoffs we need from each of the assembly and production divisions respectively. Let's begin by looking at the payroll prior to the decision to lay off some of the workers. Prior to the layoffs, every production worker got a monthly salary of $5,500 and every assembly worker received a monthly salary of $4,600. The total salary paid out that month was $400,000. We could convert this into a linear equation by allowing P to represent the number of production workers and A to represent the number of assembly workers in the following way. Let's refer to this equation as equation number 1. Next, we want to interpret the percentages given for the layoff portion of this question. So we would like to lay off 20% of production workers and 12% of assembly workers. In other words, we want to start with the number of production workers we have and subtract 20% of those individuals. That's going to leave us with 80% of the original number of production workers. And similarly for our assembly workers, we want to take the original number, reduce this by 12%, so that we have 88% of our original assembly workers left over. Now we can try to draft up an equation that is a result of these particular layoffs. We're still going to pay our production workers $5,500. The only difference is now instead of having 100% of our production workers, we're only going to have 80% of them. Similarly, we're still going to pay our assembly workers $4,600. The difference is after our layoffs, we have 88% of them. After layoffs, we expect to pay out $347,600. Let's take some time just to simplify this equation a little bit. 5,500 times 0.8 should be 4,400. And 4,600 times 0.88 should give us 4,048. Let's refer to this equation as equation number 2. So what I've done here is I've combined equation 1 and equation 2 into a system of linear equations. And our next goal is to try to determine the values of P and A that make these equations work. Since it's not going to be relatively straightforward for us to isolate either A or P, I don't think the substitution method is the way to go. I think the elimination method is going to be a little bit easier to use. However, the numbers we have are quite large, so let's try to simplify these equations a little bit before trying to apply the elimination method. I notice that all of the numbers in equation number 1 are multiples of 100, so I could technically divide this equation by 100 to simplify it a little bit. For equation number 2, it's a little bit less obvious what to choose, but I noticed that the coefficients of P and A were both divisible by 16, so I checked to see if the constant was also divisible by 16, and it was. So I'm going to choose to divide equation 2 by 16 to simplify it a little bit. Performing those two operations, we end up with a new system of linear equations that looks like the following. And now I'm going to focus on trying to match up the coefficients of the P variable. And I can do that by multiplying my first equation by 275 and multiplying my second equation by 55. Performing the indicated operations should give us the following new linear system. And the numbers are quite large here, but hopefully in this next step we can clean it up a little bit. Let's see, let's take equation 2 and subtract equation 1. Obviously starting in the column involving our p's, the coefficients are the same, so we get 0p. Moving over to our column containing the A's, we'll take our 13,915, subtract 12,650. That's going to give us 1,265 A's. And then working in our constant column, doing this subtraction should give us 94,875. Let's go ahead and divide both sides by 1,265, and I get that A is equal to 75. Now that we know the value for A, let's try to determine the value for P. I'm going to grab the equation 55P plus 46A is equal to 4,000, and I'm going to go ahead and make the substitution that A is equal to 75. "46 times 75 is equal to 3,450. So we can get 55P is equal to 4,000 minus 3,450. That's 550. And then we can divide both sides by 55. And that's going to tell us that P is equal to 10. This, however, is not our final answer because we need to determine how many people got laid off. So, based on the numbers that we have, we know we had originally 10 members of the production team. We had to lay off 20% of these individuals. So taking 10 and multiplying by 20%, we see that we had to lay off 2 of those individuals. Similarly, we started with 75 individuals on the assembly team. We needed to lay off 12% of them. So taking our 75 and multiplying by 12%, we get that 9 of these individuals had to be laid off. And this will be our final answer to this word problem.